Hi everyone, my name is Thomas Kim. Today is June 21st, 2021. This is my 17th episode about must-know C++ 20 syntax and Qt6 and 3D graphics with Vulkan. In this episode, I will discuss DLL versioning, ABI or Application Binary Interface, inline namespace, attribute deprecated. In our previous video, episode 9, I discussed attribute nodiscard. If you haven't watched this video, please watch this video. In this video, I explained how to use attribute nodiscard. Also, in episode 22, how to create DLL for use in C++ programming. In this video, I explained how to create DLL for use in C++ programming. In episode 23, I explained how to use C++ standard template library in C program through dynamic link library for C programming. In episode 24, I explained how to dynamically load DLL at runtime using LoadLibrary, GetProcAddress, etc. With such information, you can extend your Python programming by creating DLLs with C and C++ language. In this episode, I will explain DLL versioning using inline namespace, also how to use attribute deprecated. I will not discuss much deeper information about application binary interface. For more information, please refer to this documentation. In this episode, we will concern mainly about C++ name mangling. I assume you understand what C++ name mangling means. In near future, I will also discuss C++ name mangling. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Select empty space. Click this button. 017 inline namespace. Hit enter. Click this button. mylib.hpp. Click this button. Click this button. mylib.cpp. Select this folder. Click this button. client.cpp. Hit enter. So we created 3 files. mylib hpp, mylib cpp, client cpp. In the client.cpp, I will paste these links. If you do not have experience with creating DLL, it might be difficult for you to follow my current session. I would highly recommend you to watch videos listed here. Through 1, 2, 3, 4, 5 videos, you can create complete DLL files and you can consume your DLL library in your C and C++, even in Python programming. mylib.hpp, if not def, mylib_hpp, and if end of file, copy this, paste, define, copy this, paste. In the mylib.cpp, define, build, mylib, include mylib hpp. Here, include type trace if not def ext my lib and if end of ext my lib. If def this macro build my lib, else and if end of build my lib. If this macro is defined, if build my lib is defined, we are building our DLL. In such case, define ext my lib to underscore 댓글 spec DLL export. Else, if build my lib is not defined, we consume our DLL. In this case, we define ext my lib as DLL import. Now, at this point, ext my lib is defined. Let me explain what is inline namespace first. I create a new file, test.cpp, hit enter, Ctrl B. We include iostream, include my lib hpp. This is client test.cpp. We haven't defined build my lib, this macro. We haven't defined this macro in the client application. I will move it here. Now, namespace my lib, namespace subname. So, subname is a namespace inside my lib. Inline namespace, inline namespace. Now here int fun int a int b return a plus b. I copy this function, paste it here. Now -2. This function has the same function name. This function return type, function parameters are exactly the same. Here, void test inline namespace. We can call fun. This function, I would say fun A, fun B, or S1, fun 1, 2. We have to provide namespace scope. Or S2, we now call this function. This function is in the namespace subname fun 2, 3. This namespace is inside my lib. Int main, I will copy this function stream, std, cout, s1, s1, std, and then copy, paste, s2, s2. In the command prompt, cd 017 inline namespace clehsc std c++20 test.cpp fe test.exe, hit enter. Test cls test. It works perfectly because we subtracted -2. It's working correctly. Now here I copy this function, paste. This is func C. Now this function is inline namespace. If we build this program, it failed. My lib func, ambiguous call to overloaded function. Because my lib func, inline the namespace func, this function and this function name clashes. Names are conflicting. My lib func, this function, my lib inline namespace func, this function, these two functions name clashes. I will disable it, rebuild. It works correctly. Subname, this namespace does not have inline keyword here. This function has exactly the same function header or function prototype, but in different namespace. If I put inline, we build again. My lib func, my lib subname func, inline namespace subname func, this function name clashes. So inline namespace name, the namespace name is not considered in name mangling. Now I disable this function, then we rebuild. It built successfully. CLS test. Please note that in this namespace, my lib, we have inline namespace, subname. Both of these function call worked successfully because subname, this subname is inline. This subname is not considered in the name mangling. This syntax are equivalent because this subname is inline namespace name. This subname is not considered in the name mangling, which enables us to create DLL versioned executable. that is, inline namespace is introduced to C++ for DLL versioning. This episode becomes too long. I will explain DLL versioning in my next episode.